In this problem, we will analyze the beam using theorem of three moments. In this beam, the point A and E are at free end, the B and D are at pin support, and C is on the roller support. Since A and E are at free end, so we can calculate the moment at B and D. So after calculating the moments, we can reduce the beam in the form of BCD, whereas B and D are at pin support and C is on the roller support. So now since moment at B and D are found, we have to calculate only the moment at C. So number of equations required is equal to 1. So the first step which we will do is to calculate the ordinates of BC and CD with the help of the formula. So the ordinates are calculated here. Then we will apply the theorem of three moments in spans BC and CD. The formula is shown here. So we calculated the area from the previous diagram. Since this is a triangle, so half into base into height, whereas this is a circle. Sorry, it is a parabola, so we calculate the area using that, whereas XL and XL are the center of that area. So putting all the values, we get the value of moment at C as 9 kilonewton meter. Now we have to find out the reactions at ABC. To find out the reaction at B, we will take the moment about C. So we get the reaction at B. Now to find out the partial reaction at C, we will use sum of vertical force equal to 0. So we get the partial reaction at C as minus 7.25 kilonewton. Similarly, we will calculate the moment. We will take the moment about B and calculate the partial reaction at C, that is 8.25 kilonewton. And we will use the summation V equal to 0 to calculate the reaction at D. So all the reactions are found and also the moment at ABC are also found. After that, we can calculate the SFD and BMD and it can be shown in the figure as shown here. Thank you.